In today's lesson, we're continuing on with solutions, and we're going to learn about the process of dilution. We'll learn how to do some calculations involving dilutions, also learn a few different terms associated with dilutions, and then as part of your homework and application, you'll learn how you can use molar concentration or other forms of concentration and dilution to make up different solutions in a lab setting. So first we have to learn, what does dilution actually mean? Dilution itself means you're decreasing the concentration of a solution, and to do that you're adding more solvent. In our discussions with chemistry, we usually just deal with aqueous solutions. Remember, aqueous means water. So water will be your solvent in an aqueous solution. If you want to dilute an aqueous solution, that means you're going to add more water to it. You've probably done some diluting at home. Does anyone have any of those frozen cylinder cans of juice in their freezer? Concentrated liquid, you add some water to it and stir it up in a pitcher. That's a really good example of one that you may have seen or may actually have in your house right now. If you think about that can of juice or other things that are more concentrated, these dilutions are made from what we call stock solutions. They're solutions where we know the concentration, they're measured precisely or made up precisely, and it's easy to take those solutions and then just dilute them to make lower concentrations of a solution. When we prepare solutions for experiments in chemistry, we often have more concentrated forms of things like acids. Doesn't take as much space up in the storage cabinets. We just take out little bits at a time and mix them with water to make up whatever concentration we want. One important thing to note is when you're thinking about dilution, whenever you add more solvent, and in our case think we're adding more water, it's not going to change the amount of solute present. Does not change it. You still have the same amount of solute, but it's going to be in a larger volume. Visually, if you're trying to see what that means, let's take a look at a diagram. Imagine you have two beakers, a small 250 milliliter beaker and a large beaker that's 1,000 milliliters or a liter. You take all of your solution that's in that 250 milliliter beaker from your stock, you put it into the larger beaker, and you add water until it reaches the 1 liter mark. When you look at what's happened, the only thing that's changed is the volume has increased, or the amount of solvent has increased. But if you look at the solute molecules, there are still the same number, but they're spaced out a little bit more. So here, if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 solute molecules, whatever they are, or you could even just call them moles for argument's sake. Here we can see there are molecules, there's more space between them. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Same number of solute particles, molecules, moles, but the volume is different. So this is really important to keep in mind when we're doing dilution calculations. The number of moles don't change because the same number of molecules or particles are present. It's just different concentrations because the volume changes. So how can you calculate dilution? This is a very easy formula that you can use. The C is for concentration and V is for volume. So the formula is C1V1 is equal to C2V2. Your starting concentration times your starting volume will be equal to your final concentration times your final volume. This formula, you might notice, has no units with it. That's because it can be used with any type of concentration units. You could use this with moles per liter. You could use this with your percent volumes or masses. You could even use this with your small concentrations like ppm. Any one of those work with these. You just have to see what you're working with and then make sure that you're watching your units throughout. So let's try out a couple of problems involving dilution and calculations. So our first example here, we want to calculate the final concentration of a hydrogen peroxide solution if water is added to 100 milliliters of a 6% volume hydrogen peroxide solution until the total volume is 200 milliliters. Now, at first, you might think this sounds a little bit complicated, but let's break it down. So, we want to calculate the final concentration. That means we want to find C2. That's our unknown. What do we start with? We have 100 milliliters at 6% volume. So our starting volume is 100, and our starting concentration is 6% volume. Since this concentration is in percent volume, our second concentration will also be in the same units. Lastly, we have our final volume, or the total volume, is going to be increased to 200 milliliters. So we're diluting this 100 milliliters up to a total volume of 200. When we're doing and using our dilution formula, again, you can use different units, just make sure that they're the same. So here we're lucky, both volumes are already in milliliters, so we don't need to do any converting, but always check your units before you start to problem solve. So here is our dilution formula. If you need a little bit of help with rearranging, that's not a problem. There are a few tricks you can do. This is the standard format for the formula, but we know in math we like to have our unknown on the left-hand side. In this case, our unknown is C2. It's on the right-hand side. So if you like your unknowns on the left-hand side, just flip the formula around. Mathematically, it's exactly the same thing. You've just reversed the sides that you have. Once you have that, then you want to isolate your unknown, which means I need to move my V2 to the other side. It's in the numerator. When I move it to the other side of the equal sign, it's going to go to the denominator. So there's my rearranged formula for dilution. And now all I have to do is plug in my numbers and solve. So my starting concentration is 6%. I'm going to multiply that by 100 milliliters. And I'm going to divide it by 200. My milliliters and milliliters will cancel. And when I do my calculation, I get 3% volume. So there's one example where we're trying to use our dilution formula involving a percent concentration. Let's try out another problem. Here's our second example. You're asked to dilute a 2 mole per liter copper 2 sulphate solution, and you want to make 250 milliliters of 0.5 mole per liter copper 2 sulphate. What volume do you initially use? So let's first look at what we're trying to find what volume would we initially use. That means our starting volume. What are they referring to? They're referring to our more concentrated solution, the 2 mole per liter copper 2 sulphate solution. That's our starting concentration. Then we've got our desired or final volume and desired or final concentration. So here our desired or final volume will be 250 milliliters. And the concentration that we want to end up with is 0.5 moles per liter. And this type of question is very practical. If you wanted to make a dilution in a lab setting, this is the type of calculation that you would need to try. So, again, write down our formula. Here we're solving for V1. It's already on the left-hand side, so I don't need to flip the equation around here. But I do want to get rid of C1. So, when I move C1 from the left-hand side to the right-hand side, it goes from numerator down to the denominator. So my formula will look like this. And now I'm ready to put in my numbers and solve. So 0.5 moles per liter times 250 milliliters over 2 moles per liter. So go ahead and punch that in your calculator. You should get 62.5 milliliters. But remember significant digits. When we take a look at all of our numbers here, they're all 2 significant digits. So this means approximately 63 milliliters. So hopefully that helps introduce a little bit more of the concept on dilution and helps you get started with some of the calculations. Following the lesson, there'll be a few links for you to investigate on how to make up solutions. There'll be questions involving molar concentration to actually prepare the solution, and there'll be some questions involving dilution when you're diluting a solution, and then there's some new pieces of equipment that you'll become familiar with through the few videos that will be posted. So hopefully that'll help you get a better understanding of how solutions are made and apply it to a lab technique. What we've learned in the lessons and some of the calculations to something that's very practical.